Question 4, the situation is there's a test with 5 questions. To pass the test, you have to answer at least 3 questions correct. And the probability that Mark answers a question correctly is 1/5. And X is the number of questions he answers correctly. And so find the expected value or the expected number of questions that he would answer correctly. And again, this formula is just simply he has 5 questions or 5 chances to get it right. 1/5 of the time he answers correctly, so we would expect in 5 questions for him to get 1 of them right. So there's finding the expected value of, or the expected number that he would get right, and then find the probability that he passes the test. And so to pass the test, he would need to answer at least greater than or equal to 3 questions. And so we just, we'll do this on our calculator. Really, again, our formula is the fact that we are summing up from 3 to 5, the probability, and we say that X is equal to I. I should have written that I is equal to 3. Writing this out this way helps you when you think about your going to your calculator, because on your calculator, this would be the binomial CDF function on your calculator, because it's cumulative from 3 up to 5. And when you go into your calculator, which you'll see, they want to know the upper and lower bounds, and the upper and lower bounds come from the 3 and the 5 here. And so when we work that out, calculate it out, we get an answer of 0.0579, and that's again to 3 significant figures. So he has about a 6% chance of passing the test. Part B1 wants you to show that 4a plus 2b equals 0.24. And again, we have to remember that our probabilities should add up to 1. This is going back to our discrete math. And so if I do part 1, the show that is, yes, so write out the equation that you have given this information. So we have a plus 2b for 2. And then we just, again, show the work, adding up the a's. We have 4a plus 2b, and adding up all of our decimals, we get 0.76 equals to 1. And so we can see, or we have shown, subtracting away 0.76, we get 0.24, and therefore we now know, or we've shown, part 1. And then, excuse me, for part 2, wants us to find AB given that the expected value of y equals 1. And if you recall, to find the expected value, we're taking the value multiplied by its probability and adding all of those together. And here they're telling us the answer is equal to 1. So to find AB, we're going to first start off by multiplying these together. So there's 0, 0.05, 2a plus 4b. You write this down, 3a minus 3b, 8a plus 4b, and 0.2. And all of these added together equal 1. And when I do that, I get that 13a plus 5b, I'm doing all this simplified, and here we have plus 0.25 equals 1. So 13a plus 5b equals 0.75. Now we're going to take this equation and the one above, and we actually are going to solve simultaneous equations. So we have 4a plus 2b is equal to 0.24. And at this point, I will go onto my calculator and demonstrate how you solve two simultaneous equations. Now that we've worked through, we find out that a is equal to 0.05 and b is equal to 0.02. And so there are your answers for A and B. To answer part C, which is asking which student would pass the test, the first thing we need to find out is, so what's the chance that Bill passes the test? And we know from part B that A was equal to 0.05 and B was 0.02. And to pass the test, you have to have 3 or more questions right. So we're looking at what is the chance of him getting 3 questions right, and that's 0.05 minus 0.02. So we have 3/100th chance that he gets 3 questions right. If I do 2a plus b, so 2a plus b, this is 0.1 plus 2/100ths, which is 12/100ths, and then 4/100ths, he gets a 5. So the chance of Bill, and this again is Bill, passing the test is adding these 3 probabilities together. So we have 15/100ths plus 4/100ths. So Bill's chance is equal to 19/100ths. And if we go back and look at part A, we found that Mark's chance was only 0.579. Therefore, we can say that Bill is more likely to pass.